So here we are, we're going to look at free radical substitution of alkanes. Now, alkanes undergo free radical substitution because they're not very reactive. So they need, a free radical is a species with an unpaired electron, so very reactive. And we use this to turn alkanes into haloalkanes. So our example would be methane plus chlorine gives us our haloalkane, which is chloromethane and HCl. So we can see that a chlorine has swapped for a hydrogen, or substituted for a hydrogen on the methane. And that's our overall equation. Now the mechanism is in 3 steps. So the first step is called initiation. And this is where the free radical is formed. So chlorine turns into 2 free radicals, chlorine free radicals, when UV light is shined on it. And what's actually happening there is the chlorine bond is breaking evenly. So each chlorine is taking 1 electron from the covalent bond. So we get 2 chlorine free radicals. And where bond splits evenly like that, that's called homolytic fission. Where it doesn't split evenly, we get 1 atom takes both electrons, that's called heterolytic fission. So this is an example of homolytic fission. So once we've formed the free radicals, then they can start reacting with our alkanes. And this step is called the propagation step. Now there's 2 steps to this. So the first one is our chlorine free radical reacts with our alkane. And that forms a CH3 radical and gives us our first product, which is our HCl from the equation. So we can see in our first propagation step we've reacted CH4 and we've formed HCl. So in our second propagation step, we're going to react our chlorine and form our haloalkane. So what happens next is the free radical we've just formed in the first step reacts with our other reactant, which is chlorine, to give us our other product, which is chloromethane, and gives us back our chlorine free radical so it can carry on reacting with our haloalkanes. And if we know we've done our propagation step correct, because if we ignore the free radicals here, we've got the overall balanced equation. We've got CH4 plus Cl2 gives CH3Cl plus HCl. And it's always the HCl in the first step and the haloalkane in the second step. And then the final part of this mechanism is called the termination step, and that's where any 2 free radicals combine. So it could be another way of forming our haloalkane, because the CH3 radical could react with the chlorine radical to give us CH3Cl. And we could also have CH3 radicals reacting with each other to give us an alkane. Now, this isn't the best way of making haloalkanes because we can get further substitution. This can carry on substituting chlorines for hydrogens. So that the new haloalkane can start reacting with chlorine free radicals. So we'd end up with CH2Cl2, then CHCl3 and CCl4. So there's a mixture of haloalkanes that you will get from this reaction.